You know these.
My YouTube was natural. I know, I've never been the one I just
It's like this and this.
Are there any questions?
Is there a chance that tomorrow's test will be canceled if the weather is like crazy? Just want to throw that out there.
Do you have powers over that?
Do I have powers over the weather?
Yeah.
I sometimes do. My dancing.
If classes, all right, so as we get into inclement weather, if class is canceled, obviously, it'll get pushed off a week.
Okay.
If class is not canceled, but some of you live in a place where it's particularly dangerous, that, because I've had, on snow days, I've had students basically iced in because they live out in the middle of nowhere and no one ever comes by to clean the roads. I understand it, you'll make it up in the testing center.
And are all of our tests in person? Or is it-
Yes, they're all in person. I haven't really figured out how to do online testing that I like.
Any questions will be on my test.
If you look at the old test, that'll probably give you the best indication.
I couldn't find those, where,
Under supplemental material,
oh.
I assume someone's found the old test. Okay. They do exist. Unless I somehow blocked them from you. It's all part of the conspiracy. Ashlyn, you had your hand up next.
I had questions on the 2022 test examples.
Okay,
Like some of the problems confused me.
okay.
Like the acceleration equals the net force over meters or
Over mass.
over mass.
Yes. Yeah, M is used way too many times, especially we use M for meters and M for mass a whole lot in these first several chapters. And you have to pull it from context. There's unfortunately no simpler way of doing it.
And yeah, number. You probably don't have the problem,
I do not.
but
I have trouble enough
can I
remembering
go
this
over
morning.
them with you after class or something?
Yeah, I don't mind going over it now.
Oh, okay. I wasn't sure if I was doing this right.
Acceleration of the box, I assume there's information on the box. So I gave you the mass, I gave you the two forces acting on it. All right, so if you recall, force is a vector, so direction matters. My numbers might be off, but the spirit is that. So I think the first question is, what is the net force acting on it? Well, I have two forces acting in opposite directions. What is the net force?
-2.
All right, if you assume to the right is positive, then Ashlyn, say it again.
-2 newtons.
Yeah. So the total force, -2 newtons. You can arrive at that several different ways. You could add them head to head, or sorry, head to tail. So I go to the right, some value of 10, and then this is my new starting point, and I go back. I have to go back farther than I started because it's longer. And that difference is 2, my resultant, is 2 to the left. Or my total force, I have 10 newtons plus -12 newtons, -2 newtons. The next question was dealt with the acceleration.
Yeah, what is the acceleration of the box?
So we're using Newton's second law, F equals ma. The force is -2 newtons, because this is the total force. It's going to be equal to the mass, 5 kilograms, times the acceleration. And so so the math problem you're working with is -2 is equal to 5a. That's the math problem. Yes, John?
So when we have like a setup like that, when it's force equals ma and like velocity equals gt, like when they're just two like symbols together, is it always times?
Yes.
Okay.
What if the 12 newtons was pushing down on the box?
Ah, okay. First off, any questions on this? Did you need me to finish it off?
No, that was the only questions for that part.
Okay. All right, let's go to Genesis. Too many S's.
I
Let's go
know.
to the question of Genesis. So if I have 10 newtons going to the right, still a 5 kilogram box, and a 12 newton force going down. So it depends on the nature of the question. If I ask what is the magnitude of the force, I'm gonna get a little bit different answer than if I just ask what is the force.
Right, what is the magnitude?
If I'm looking for the magnitude of the force, I have two vectors, so I would add them head to tail. I go to the right 10, I go down 12. The resultant is from where I begin to where I end. That is my resultant right there. And to find the magnitude of the resultant, Pythagorean theorem. That is, they are at right angles to each other, and so I know that 10 squared plus 12 squared is equal to r squared. So that's 244 is equal to r squared, so r equals whatever that is. Newtons.
So, sorry. So the resultant is 244 squared? Like whatever.
Square root of 244, that's the magnitude.
Okay.
The direction is not required string. Now, if I asked a different question, if I said, what is the total force acting on it? That's actually simpler. If you got the concept, it's simpler to do. Because here's how I would do it. Because it has a magnitude and direction, but finding this angle right here without trig, it's not very easy to do. I guess the way that you would do it without trig is you would set up some scale, so if you drew a line horizontally at 10 centimeters and drew one down 12 centimeters, connected them, pulled out a protractor, that's a lot of work. So what I'm gonna do here is I'm going to use my I hat, J hat. I'm gonna say to the right is I hat, and just for the sake of it, I'll make up J hat. And so my total force is 10 newtons I hat minus 12 newtons J hat. Done.
If you determine that down was negative, would it have any effect on,
If you consider down as positive,
or down being negative?
down is negative here. I mean, positive.
Yeah, that's right. Or before that is what I meant when you're doing Pythag.
Oh, the magnitude of the resultant would be the same.
Yeah, you know what you meant.
Is it on this one? I was going to extend it.
No, go ahead.
All right, you have a question on this?
Yeah.
Okay.
So we use I hat and J hat when we're trying to do what again?
If I need to express a force that's if it's in one dimension, if it's just things moving and just everything is along the line, either one way or the other, I can get away with plus or minus to indicate direction. But if I'm in two dimensions, if I want to indicate direction, that's when you bring in the I hat, J hat. And so something like this, if I need to add them, I have to somehow take the direction into account. If I just did 10 plus 12, that implies they're going in the same direction, which they're not. So this is known as rectangular form. And as a side note, if you ever see a problem where I have a little gift icon at the beginning of it, don't overthink it. The answer is probably in the question itself.
Can you say that again?
If you ever see a gift icon next to a question, so something like that, it looks something like that.
Okay.
Then that is a gift icon. It means the answer should be very simple. Usually, it's because the answer is in the question itself.
Okay.
Now, if the gift icon is not there, that means I could have just forgotten to put it in. But if you see it, it does mean that it's a very simple answer. All right, so if I ask what is the magnitude of the acceleration, then I would take the magnitude of the force and divide by the mass. So I take whatever that is and divide by 5, and that will give me the magnitude of my acceleration. I pull up my calculator, figure out what it is. If I ask for an acceleration vector, so if I wanted to know acceleration vector, I would take my force vector and divide by the mass. So I would take this and divide by 5 kilograms. Well, 10 divided by 5 is 2. 12 divided by 5, still negative, would be 2.4. And then units. So that would be the acceleration as a vector, and whatever that is the magnitude of the acceleration, or scalar acceleration.
For the scalar, how'd you know to divide it by 5?
The mass, it's force divided by mass, then I gave the mass. All right, other questions? I believe there were, Ashlyn, you had some, Genesis, I think you had one. Manaya's got one also. Somebody?
For, what is it? For number 21, it has the diagram with the arrows pointing in all different directions.
Right?
I was confused of how to sketch it.
How to sketch the sum?
Yeah, it says sketch the net force acting on the mass, and then the others just help it. Like the other questions, just,
All right.
confusing.
How many forces were there?
4.
Okay.
That, the one pointing like up.
This is as a sample.
Oh, okay.
So if you're given something like this, and it'll vary. What I seem to do when I throw this question on there is I look at whatever test I'm using as my model, and then I just rotate it. But, so I'm adding vectors here. If they're forces, if these represent forces, then I'm adding force vectors. If it represents displacements, such as these are the directions I went in, then I'm finding a final displacement. But the math is the same. So I start out with one of the vectors, and it doesn't matter which one, just pick one. I'm gonna label them just so that I can make it easier to communicate what I'm doing it later. So I'm gonna start with A. I'm gonna write this down. I need to draw A because it has a magnitude and direction. I need to draw it so it has the same magnitude, same direction as best I can. Now, when I said sketch, this means that you can freehand it. You don't have to pull out a ruler, but just trying to do the best I can. I'm now gonna take the next vector. I'm gonna go to B next. I'm just gonna go clockwise. The order doesn't matter. The one you start with doesn't matter. You should end up in the same place either way. So I'm now here, and I'm gonna add B onto it. So I go to here, now I'm doing B. Somewhere around there. And one of the reasons I labeled them over here is so that it's very clear to whoever's creating this that, this is supposed to be A, yeah, those look close enough. Those look close enough. Now I'm here, and I add the next one, C. And then lastly, D. All right, so that's the essence of adding them. I haven't come up with an answer yet, but this is the head to tail method. My answer is a vector from where I begin to where I end. We did the same thing on the previous slide, on the previous one. when I added the vectors this way, the head to tail method, this was in one dimension, so it was a little bit simpler. But I drew down one of them, and then I drew the other one, and my answer was from where I begin to where I end. So it was a vector going that way. So my answer is a vector from where I begin to where I end. That is my answer. R for resultant. Resultant just means sum of vectors. Questions about the addition of them before? I think there was another part to the problem. Any questions about this? All right, and what was,
One of the smallest arrow had 3 newtons on it.
okay, so if I said, if this were 3 newtons, what's the magnitude of the resultant?
Given that one of the forces is 3 newtons as indicated, estimate the net force acting on the object, and the object is 8 kilograms.
Okay. So the mass of the object, if the, all I'm asking is for net force, it should be magnitude of net force, it might be a slight issue with wording. But if this light here represents 3, what does that represent? Well, if I just use my fingers here, like that, that is going to, that comes to about there. This is roughly 2/3 of the length. So if that is 3, this would then be 2/3 of that, or around, it's around 2 newtons. That's as sophisticated as you need to get on that. It doesn't have, you don't have to pull out a ruler. I don't know, 151 test, I had someone pulled out a ruler and was measuring, ruler and protractor, coming out with an exact answer. He was off by 0.1, so I marked it all wrong.
Like, did he get points for that?
No, but he got the right answer. So get close enough.
And then, given part B, what is the acceleration of the object?
Okay, so since I know what the magnitude of the force is, I can find the acceleration, again, force divided by mass. So if this was, I think in that problem it was an 8 kilogram object. So force divided by mass, would be 2 newtons, divided by 8 kilograms. And in this case here, 0.25 meters per second squared.
Is there a reason you use the resultant as the newtons instead of the 0.3 or the 30 or whatever it was?
They wanted the acceleration of the object. The acceleration of the object is based upon all the forces.
Okay.
So it's whatever I got for that.
Okay.
So what I use would be this. Now you might do the same thing and come out with a different answer. That, I mean, there's a certain range. That's correct. There was one person who, the answer was something like that on the test, and his final answer was something like this, which on first glance I was thinking, I'm not quite sure what he did, but he showed me the work, and he was just a little bit off on each one of these things, and it ended up being up there, and he got full credit for it. So just, if you're showing your work, then this might be a correct answer. All right, and then, quick,
You answered my question.
okay.
Yeah, okay, so my question was on number 11, but basically it was asking when an object stops, and it was when we use the equation, I think it was like, you use acceleration and then over 1, and then the final velocity over t.
Okay, so something that, an object goes from 62 to negative 28 meters per second in 10 seconds along a straight flat road at a constant uniform acceleration. Okay. And the question number 11, at what time did the object stop? All right. So on that one, I know acceleration is the change in velocity over the change in time. That's the basics where I'm starting. We're talking about an object that starts at, I think it was 62 meters per second. and goes to negative 28 meters per second in 10 seconds. All I'm looking for is a point partway through this journey, because I know it turns around. Now, how do I know it's gonna turn around? Right, I'm going from a positive direction to a negative direction. So I'm trying to figure out, in order to turn around, I have to stop in a one-dimensional problem, and so I need to figure out that time in which it stops. This is gonna be final velocity minus initial velocity, divided by time. Acceleration, I've already figured out at this point, that was, -9, okay? And you get that by looking at the whole trip. For the entire journey, going from it's final velocity minus the initial velocity divided by time, which ends up being -90/10, -9. So up here, for when it's gonna stop, the velocity is 0. So I have -9 is equal to 0 minus my initial 62 divided by time. So just plug and chug and get this. Now, to solve it, depends on how you want to go about it. I'm gonna go ahead and do the fancy math of 0 minus 62. So I have -9 is equal to -62 over t. And then a way to solve it is to treat it like two fractions equal to each other. I think most people have some memory of cross multiplying. So I'm going to say I have to create two fractions. Well, I can turn anything into a fraction just by putting it over 1. Now I have two fractions equal to each other, and to solve that, I take the diagonal that I know, so I multiply those, I get -62, and then divide by what's left over, the -9, and you get whatever that happens to be. So 5.8 would be. That's not right.
It's 6.8.
6.8.
So you just put, so for V, the final velocity is 0, because that's when it stops.
Yes.
Okay.
Now, we can narrow it down some, I mean, just to see if this even makes sense. I know my acceleration is -9 meters per second squared. That means it's gonna change by -9 meters per second